types of geothermal systems where thermal energy is extracted from crust. Okay, so the main source of thermal energy emitting from Earth is from the lava, wherever you have these tectonic plate junctions. The tectonic plate junctions occur from there, the thermal energy from the core of the Earth will be emitted. Okay, so there are different possibilities for extracting or obtaining the sources of the geothermal energy. So the first source is wherever you have these tectonic plate junctions. So from the junctions, this emitted energy may interact with water resources. So this may interact with water resources. So you may find at some places only steam, means dry systems. In some places you may find water coming out of hot water springs. Hot water may come out of this earth surface. They are called hot water springs. They are wet systems. Another possibility, dry rocks. Sometimes this heat energy may only end up in heating the rocks. And these hot water systems may be of two types. One, normal hot water, another is high pressure. Geothermal systems. So మనకి ఈ టెక్టానిక్ ప్లేట్ జంక్షన్ నుంచి బయటకు వచ్చేటువంటి geothermal ఎనర్జీ అనేది, ఆ హీట్ ఎనర్జీ అనేది వాటర్ బాడీని కాంటాక్ట్ అయినప్పుడు హాట్ వాటర్ స్ప్రింగ్స్ వస్తాయి. అనదర్ పాసిబిలిటీ, హాట్ వాటర్ స్టీమ్ గా మారి డ్రై వేపర్స్ వస్తాయి. అనదర్ పాసిబిలిటీ, ఆ స్టీమ్ అనేది ఎర్త్ క్రస్ట్ లో ఎక్కడ చోట ట్రాప్ అయిపోతే విల్ హ్యావ్ జియో ప్రెషరైజ్డ్ సిస్టమ్స్, హై ప్రెషర్ జియోథర్మల్ సిస్టమ్స్. లాస్ట్ పాసిబిలిటీ ఇస్ డ్రై రాక్ సిస్టమ్స్. Only a rock will get heated up in the presence of this geothermal energy. So we'll have at least 4 different types of systems to extract these 4 different kinds of geothermal energies. In all రకాల ఎనర్జీని ఎక్స్ట్రాక్ట్ చేయడానికి 4 different types of systems ని మనం డెవలప్ చేసుకోవాలి. So we'll start with dry steam systems. So the dry steam system, so we'll be starting with the extraction well. Extraction well, where the dry steam is extracted from earth crust. So we'll be using valve controllers to control the pressure and speed of the steam. Then we use a centrifugal separator to separate solid materials, stones, dust, whatever solid material will be separated using centrifuge. Okay, so hot vapors are extracted from earth, and and they are controlled by using a valve. Further they are sent to centrifuge, the centrifugal separator, to separate solid waste like rocks and stones and dust. Next, dry steam is sent to turbines. Dry steam is sent to turbines. They will run the generator to generate electricity. So steam turbine, generator. And after power generation, the remaining vapors will be condensed. So they will be mixed with water. The remaining steam will be mixed with water and sent back to earth. So this is called a rejection valve. So this is condenser. So in one step you may not be able to condense or mix the vapor into water. So you will be using a condensation tower. Where the vapors are circulated again and again, mixed with the same water. So that majority of the vapors will be mixed with water, and there are some possibilities where they may not, some vapors may not mix with water, they may not dissolve in water. So they will be mixed with the steam and sent into atmosphere. So a portion of the steam is used to send the remaining vapors into atmosphere. So majority of the steam is used to run the turbine. Turbine run చేయడానికి వాడతాము. ఇంకొంత మిగిలిన కొంత పోర్షన్ మాత్రం ఇక్కడ కండెన్సేషన్ లో వాటర్ లో మిక్స్ అవ్వని వేపర్స్ ఏమైనా ఉంటే వాటిని అట్మాస్ఫియర్ లోకి పంపించడానికి వాడతాం. సో ఈ కండెన్సేషన్ టవర్ లో all vapors may not mix into water because we are dealing directly with the vapors. A water mix avudani guarantee లేదు. So whereas hot water systems, wet systems అయితే కనుక wet systems ఎట్లా ఉంటాయంటే we'll be using flash evaporator at the first stage instead of centrifuge. So ఇక్కడ centrifuge బదులుగా flash evaporator ని వాడతాం. అంటే ఏంటి, it expands the liquid and converts into vapor. సో ఈ వెట్ సిస్టమ్స్ లో ఏంటి, మనము హాట్ వాటర్ స్ప్రింగ్స్, హాట్ వాటర్ బయటకు వస్తూ ఉంటుంది, దాన్ని సో హియర్ ఎక్స్ట్రాక్షన్ వెల్, so here we are using flash evaporator. Flash evaporator, it will suddenly expand the hot water and it will be converted into steam. So hot water ni sudden ga expand చేసినట్లయితే మనకి అది వేపర్ గా కన్వర్ట్ అయిపోతుంది. So that's called flash evaporator. So the remaining liquid will be sent back to earth. So flash evaporator lo input water తీసుకుంటున్నాము. Some portion will be converted into vapor, remaining liquid is sent back to earth. So now this dry vapor is used to run the turbine. The dry vapor is used to run the turbine, and output of the turbine is given to generator. So we are using a turbine followed by a power generator, and then output of turbine is sent to condenser. Output of turbine is sent to condenser. So here and output of condenser is sent back to rejection well. So here we are using a cooling tower. Cooling tower for better condensation. This is cooling tower. We are using a cooling tower for better condensation. So here we don't need any additional setup after condensation, because all gases, all steam will now mix into water again, because we are already taking these vapors from water mix. ఇక్కడ ఆల్రెడీ వాటర్లో మిక్స్ అయిన వేపర్స్ తీసుకున్నాం కాబట్టి ఇక్కడ కంప్లీట్గా వాటర్లోనే మిక్స్ అయిపోతుంది. We don't have any additional vapors remaining. So vapor system, dry systems like that, additional vapor into sending into atmosphere ఉంటుంది. Undissolved vapors. Here we don't have that undissolved vapor. All vapors will be mixed into water and they will be sent back to earth. And in the wet system, if you have high pressure water ఉన్నప్పుడు ఏం చేయాలంటే we can use double flash evaporator. So during expansion, temperature reduces. So water converts into vapor and temperature reduces. And that is what happens in our ACs and refrigerators. Gas ni sudden ga expand cheste temperature down అయిపోతుంది. సో ఇక్కడ మనము తీసుకున్నటువంటి దానికి ఎంతో ఒక 300-500 డిగ్రీ సెంటిగ్రేడ్ లో తీసుకుంటే మనకు బయటకు వచ్చేది ఒక 100-200 బయటకు వస్తుంది వేపర్ స్టీమ్. If you have very high temperatures like 1000 degrees, 1200 degrees, అంత high temperature vapors ఉన్నాయనుకోండి, అసలు వాటర్ వేపర్ ఎంత 100 లోనే బాయిల్ అవ్వాలి వాటర్. ప్రెషర్ ఎక్కువ పెట్టినప్పుడు ఇట్ కెన్ బేర్ మోర్ టెంపరేచర్స్, 1000, 1200, 1500 వరకు కూడా వెళ్ళిపోతుంది when you rise the pressure. So అంత హై ప్రెషర్ వాటర్ రిసోర్సెస్ తీసుకున్నప్పుడు we can use double flash evaporators. Okay. So when you have high pressure and high temperature water resources, you can use double flash evaporators. So one flash evaporator, sorry, So this is used to run high pressure turbine. Next flash evaporator. So the output of first flash evaporator is given to next flash evaporator. So the output of second flash evaporator is given to low pressure turbine. You can use two turbines, one for a high pressure turbine and output of second flash evaporator is given to low pressure turbine. And the remaining water after second level will be sent back to earth. And at the end we have the cooling tower. The output of both the turbines is sent back to cooling tower or condenser. And finally, the remainings of condenser and cooling tower will be sent back to earth. This is rejection. Right. So when you have pure steam resources, so everywhere we are trying to separate the waste material, maybe corrosive material or solid waste and all. So if you have pure steam resource, then you can directly use it to run the turbine. So in that case you have extraction well. And it is directly connected to turbine. If you have pure steam resource available, it will be directly connected to turbine, and output of the turbine is given to cooling tower. That is the most simplest dry system where you have pure steam resources. Okay, so we have two dry systems and two wet systems. Next one is high pressure systems. So when you have very high pressure systems, there is a possibility of more damaging materials, more corrosive materials. So in that case, we don't allow the resources coming from Earth to touch the turbine. So there we use heat exchanger. So we have extraction well, so we have an extraction well. So we use a heat exchanger to extract the heat and send back the remaining liquids into a heat exchanger. So there will be pipelines surrounding each other. So the whatever heat from one pipeline will be transmitted to the other pipeline. So there will be any direct contact between the fluids. So this will be used to run the turbine. After heat exchanger, so this is called the working fluid. The fluid that is actually running through the turbine is called working fluid. So after condensation, it will be condensed. After passing through the turbine, the fluid will be condensed and will be using a cooling tower. And output is sent back to heat exchanger. Output of condenser is sent back to heat exchanger. Because by this time the temperature will reduce and it will be ready for collecting heat from the next stage. So when you have very high contaminants and damaging materials, corrosive materials from geothermal resources, then we use heat exchanger. So there will be a working fluid which runs through the turbine, and all the geological fluids will be sent back to earth after collecting heat. Heat మనం ఎక్స్ట్రాక్ట్ చేసుకున్న తర్వాత ఆ జియోథర్మల్ ఫ్లూయిడ్స్ అని కూడా మళ్ళీ ఎర్త్లోకి పంపించేస్తాము. And there is a separate working fluid that runs through the turbines. That's about high pressure systems. Whereas dry rock systems, coming to this dry rock system, rock is dry, so we have to drill holes into earth to pump water. So in that system, in addition to this mechanism, we have to send water using a pump. So we have water pump that sends water into dry rocks. So we will be drilling holes into those dry rocks and collecting hot water. We will pump water and collect the hot water, and we will use heat exchanger. So we use a heat exchanger to run the turbines. And output of the turbine is sent back to cooling tower. This is for dry rock. So we have an additional mechanism. We send water onto the dry rock to extract heat. And next mechanism is everything same. Okay. So in total, geothermal resources are coming from tectonic plate joints. Hot magma will come out of these tectonic plate joints, and if it come in contact with water resources, we have hot water springs and hot steam, dry steam resources.
Steam.
Yeah. So if it comes in contact with dry rock, it will heat the rock. So there are basically three types of resources that we can use: steam, water, and dry rock. So we have to develop mechanisms to extract that. So coming to dry systems, when you have very solid waste, we use centrifuge to separate the solid waste and send the pure steam to the turbine, and the output of turbine is condensed, means it will be mixed with water and sent back to earth. And all the steam may not be mixed into water because it is a dry steam. So the output of condenser, if any other undissolved vapors, will be sent into atmosphere. So that is an extra step here in dry systems. And if we have pure dry steam available, we can directly give it to turbine, and output of turbine is condensed and sent back to earth. This is the most simple system. And when you have wet systems, you have water, hot water available for energy extraction. So we use flash evaporator, where the water will be suddenly expanded. So its temperature reduces, but it will be converted into vapor. So that steam or dry water vapor is used to run the turbines, and further it will be condensed. So here you don't have any undissolved vapors because already the resources are extracted from water. The vapor is extracted from water. So output of condenser will be completely dissolved into water. It will be sent back to earth. And when you have very high pressure or very high temperature water resources, you will be using double flash evaporators. The first flash evaporator will run high pressure turbine, and output of first evaporator is given to second evaporator. It runs low pressure turbines, and completely output of both the turbines will be condensed and sent back to earth. And when you have very damaging materials and corrosive materials or harmful materials, you won't let the geothermal fluids to enter into the turbine. So we'll be using a heat exchanger. So after heat extraction, the geothermal fluid will be directly sent back to earth. So we'll be using a working fluid, and this may be water or any other chemical liquid which extract heat from the geothermal fluid and run the turbine. So if we have pure dry rocks, we have to inject water into dry rocks by drilling holes and then extract hot water. And rest of the mechanism is same. So this is all about geothermal systems. So the major problem with the geothermal systems is earlier the first generation systems were open loop systems where you extract the geothermal fluid, extract heat, and the remaining low temperature geofluids were dumped onto earth surface. So వచ్చిన హీట్ అంతా ఎక్స్చేంజ్ చేసేసుకొని ఆ లిక్విడ్స్ మాత్రం బయట డంప్ చేస్తారు. The problem is they have very damaging elements like sulfur, mercury, cadmium. So all these harmful materials were dumped on earth surface. That was the problem. So they were highly polluted. So further people have developed this closed loop systems where geothermal fluid is used to run the turbine and sent back to earth. Otherwise some heat exchangers are used and all fluids will be injected back into earth. So that was the first problem even in Australia. So one big city of around 11 square kilometers area was slumped down by a few hundred meters because of open loop systems where they extracted all the fluids and dumped on the earth surface. So vacuum created and everything slumped. Almost 11 square kilometers. మొత్తం ఆ గ్యాప్లోకి ఒక సిటీ మొత్తం కిందకి వెళ్ళిపోయింది ఫ్యూ మీటర్స్. సో అందుకని ఫర్దర్గా అన్ని క్లోజ్ లూప్ సిస్టమ్స్ డెవలప్ చేశారు. స్టిల్ సో ఆఫ్టర్ డెవలప్మెంట్ ఆఫ్ దిస్ క్లోజ్ లూప్ సిస్టమ్స్ నౌ ద geothermal energy is pure energy. It is green energy, environmentally friendly. Okay. So the thermodynamics part of this will be you will be studying in other paper, thermodynamics and fluid dynamics paper. Okay. So with that I am closing this session.